blue-green algae is often viewed as just sort of a pest. If you own a pond, or if you, again, like I said, you've been to a lot of lakes, or even sometimes coastal waters, like in the ocean, it will also exist. But basically what it requires is blue-green algae is a type of algae that forms on the surface of the water, and it'll sometimes leave that green sludgy slime on the areas of the embankments of the lakes or rivers that it's in. And you can sometimes observe it, you can see it, because sometimes, yeah, it's one of those organisms that will leave that green sludge on the side. And so blue-green algae goes through a number of processes during its life cycle. However, there is one specific process that it undertakes as a community that is it has a large impact on the environment in general. And this is called an algal bloom or plume. And what happens here, as I understand it, is I'm not sure if it's a respiratory function or a reproductive function, but essentially they do, as an effect of this plume, reproduce at an accelerated rate. And so they can go from quite a small area to quite a large area of a water mass. And this can have ramifications on the environment, because it can block out sunlight from reaching lower down into the water. It can change the pH, I believe, and some of the chemical composition of the water. It can basically have a number of negative effects. So it's largely seen as a pest. However, there have been some studies that have looked into cyanobacteria, this blue-green algae, and exactly what it's putting off, what it's putting out. So one of the things that it puts out is brought under the name cyanotoxins. And why do we call them toxins? Well, cyanotoxins essentially are these molecules that can have bad interactions with our body. And these bad interactions can cause sort of immediate illness, but can also cause other problems. So I'm just bringing up here some information for you. I'm not going to read all of it, but you can see here that there is some knowledge already out there. We do understand that it can cause immediate effects, but the long-term effects of cyanotoxins aren't perhaps fully understood. But as you can see, it says here that there are like gastrointestinal issues, stuff to do with your liver, stuff to do with your kidneys. The filtration doesn't like it. It can make you very ill. All right, so why is this important? Why am I telling you about it today? It's obviously clearly understood that a lot of people know about this already. Well, there was some ongoing research that found that there was a specific place in Guam, I believe, where there was a lot of cyanobacteria activity, especially from the plumes, and it was found that the communities that lived in these areas had an unusually high rate of neurological deficiencies or neurological pathologies later in their lives. And so through a number of different testings, they were able to determine that they believed it was the cyanotoxins that were having an influential effect on these populations. If you're a very anxious person, a concerned person, you're probably already asking, what can I do? What can I do? Well, I want to speak a bit more in the presentation, or at least my explanation of what this is. But if you just want the information right now, there is perhaps something that you can do about it, and it's to do with this molecule called L-serine. And L-serine... All right, so let me just get straight to the science part, which is, from what studies have been done, it appears that it's this molecule BMAA, beta-methylamino L-alanine, which seems to be playing a large part, once it's metabolized into the body, of causing damage, at least in the neurological context. And so here we have a whole section of the neurotoxicity of it. But again, it's not been fully proven that the environmental cyanotoxins are directly responsible for this BMAA aggregation. But what it appears to be, at least, is that the method of action, the mechanism of action is that these BMAA molecules are being misidentified as a normal type of amino acid molecule that your body would use in synthesizing proteins. And so it's incorporating them into the production of these proteins, and the proteins don't work correctly. And therefore, as you accumulate them over time, these incorrect proteins or these non-functioning systems are then, they're falling down. They're failing to work. They're becoming defunct. So going back to, what can I do about that? There is some information to suggest that there's this compound called L-serine, which is present in things like eggs and pork and seaweed. And there is some evidence to suggest that this may act kind of like iodine, when you're going through fallout. So basically, it replaces, it makes a ready supply and replaces the potential areas that would be getting compromised, so that this molecule that would be getting incorporated is being outcompeted in some way by this L-serine, and that's hopefully reducing the accumulation over time. That's as I understand it. I theorize that there could be other mechanisms of action. So let's say that it's not as simple as an A to B relationship. Like, it could have other strands involved in it. Like, it could be, for example, that actually most people have genes that accommodate for BMAA and can make the correct discernment to keep it out of those vital systems, vital areas where it is being accidentally incorporated. And then you might argue that the reason not everyone gets ill with neurological conditions is because in most people those genes are functioning correctly, and so the BMAA or other cyanotoxins are being correctly disposed of by the body. But the people who are vulnerable to it end up being the ones who do accumulate it over time and end up having these problems. Equally, you could also say that there's a number of different ways that these mechanisms could be taking place. It doesn't necessarily have to be just like you take it in and that's it, it's over. There could be other things, other factors. However, what at least appears to be very concerning is that there is growing amounts of evidence to suggest that cyanotoxins do have a relationship with neurodegenerative conditions like Parkinson's, Alzheimer's, ALS, Lou Gehrig's disease, motor neuron diseases. Which is very frightening, right? Motor neuron disease, as every hypochondriac knows, it's like the one thing you don't want to get. And while it's incredibly rare, you would at least like to know, well, how can I reduce my odds? And there simply is no definitive information out there at the moment that reduce your odds. There is there have been some cohort studies that have pulled data from like large institutions like the military or athletics foundations and found that there seems to be some correlation between military service and getting a neurodegenerative condition. And there's a number of reasons why that could be. Professional athletes also seem to be specifically vulnerable to it. I think the running theory, the orthodox theory about that is to do with accumulated concussion or like micro brain injuries that happen over time, but then they overcome the body's natural ability to recover from them. They overwhelm the body's natural ability to repair itself. And while I would agree that probably is a factor, it wouldn't necessarily explain for why cyclists, for example, are overrepresented in patients with neurodegenerative conditions. Like, my take on that might be something like, well, if cyanotoxins are contributory, could it not be that people who are more liable to spend time outside, specifically near the coast, specifically near water, or specifically in the rain, and I'll get to that in a minute, that they won't come home when it's raining, they will persist outside in the rain for long periods, are more liable to be inflicted? I would argue that cyclists absolutely fit that model. Military people absolutely fit that model. Professional athletes, especially team players who are required to play games whether or not it's raining, and travel all over the country doing so, and train in the rain as well, I would argue absolutely they fit that model too. So I know I'm speaking with a lot of certainness, and I don't mean to say that I have all the answers, but I mean to say that it appears convincing to me at least. So please allow for that in your understanding of what I'm trying to explain. Now, there was some studies into, let's see, where do we have it? There was some studies into, so microcystins, by the way, is a term that's also used in relation to blue-green algae and cyanotoxins. And I think it's to do with a certain type of configuration. So it's, as I understand it, microcystins can accommodate for like 80 different combinations of molecule in roughly the same organization, but in slightly different structures. And they can have a number of different outcomes. So it could be that only a couple of these structural changes are the ones that are damaging in the long term, and maybe that's why it seems to be so much of a random assortment of people get it, because it does appear to be that maybe it could just be a bad luck. It could just be bad luck that if you give yourself more exposure to an environment where you could find cyanotoxins, that you will one day have a exposure to the specific structural version of it in a high enough quantity that it then afflicts you. And obviously, if that's... So why is this important? Why is this important? All right, it's important because cyanobacteria benefits strongly from increasing temperature. It is more at home and more able to be present in environments with warmer climes. And if climate change is contributing to that, we are liable to see an increased incidence of neurological deficiency, neurological issues. And that will be because, well, there are a number of studies looking into this. However, some people have speculated that, apologies, I'm just going to see if I can find the study here. I had a number of things I was looking at. Yeah, so here was I apologise, not using the direct study, but I'm just using a news article about it on a scientific website. That University of Amsterdam scientists were looking into cyanobacteria growth models accommodating for a rise in temperature. And they advised that it looks like, as it says here, fertilising the water worldwide with CO2. So not only is CO2 itself contributing, but also the rising temperature is catalyzing the growth in cyanobacteria, and it's going to allow for even more of these plumes that then, it appears, can actually seed clouds, as we see from this Science Daily article. So bacteria feeding on Arctic algae blooms can seed clouds. So what it appears to be is there could be some relationship between the water molecules themselves evaporating in the ocean, and they could be carrying some of these cyanotoxins, at least, with them through the water cycle and depositing them as rain or, as precipitate. So that also includes snow, for example, into otherwise healthy biomes. Now, this can be incredibly damaging because what I noticed actually in one of the studies is that they were saying that these precipitates can accumulate in a number of ways. One of the ways they could accumulate is in snow. So theoretically, what you could have is people who are like frequent winter sport enthusiasts could be at a higher risk than people who only operate in in other areas. So let's say snowboarders, skiers. Those are the only two winter sports I know, I apologise. Perhaps they are at a higher risk. And the argument given, actually, as I can see it, and this also may play somewhat to the understanding that military veterans have a high risk as well, is that in the desert, for example, in the desert it will rain, but there's very little biological activity there to metabolize what's being deposited by the rain. So if you have cyanotoxins and they're existing for an extended period, they will accumulate and nucleate on particles of dust in the sand or sand itself. And until something actually, respirates it or metabolizes it, it simply sits there. So you could be sending guys into the desert, especially in the military. This is clear in the last few decades. That's been operationally relevant. That these guys are at a higher risk of these cyanotoxins because it's in the sandstorm. Like, they're breathing it in constantly. And this could account, at least in some part, for why they are at a higher risk. Though again, speculation, absolute speculation. Ignore me if you want to. It's fine. All right. But then why is it significant for snowboarders? All right. So I've given the example in the sand, how it can nucleate on dust particles and sand, and there's nothing metabolizing it to remove it from the environment, because these are mostly arid, these arid areas. The top of a mountain doesn't have a lot living on it, and yeah, the sand doesn't have a lot living on it. Neither does the top of a mountain. Top of a mountain doesn't have anything living there. So how is that going to be removed? How is it going to be taken out of the environment? Well, all you can do is wait for the snow to melt, and then the water itself will run down and begin to be metabolized. All right, let me speak a little bit about what happens in society, right? How does civilization deal with this problem normally? So, water companies essentially have to accommodate for blue-green algae. It's something that appears often in large bodies of water that they use, like reservoirs, and they have to deal with it. And you can argue, well, where does it come from? And I can say, well, the rain may carry some of it, or other. That bit maybe isn't that necessary to describe here, but nevertheless, they have to deal with blue-green algae. And some of the methods that they use to do that, knowing that it has these cyanotoxins, is that they use this thing called activated charcoal. Now, people, my mum likes activated charcoal, so I know there's a lot of people out there who are aware of it. If she knows about it, I'm sure lots of people are aware of it. But what it is essentially is it's like ground up, and I'm not sure if it's specifically charged in any way, but it's just ground up coal, ground up charcoal, ground up carbon. So it seems like carbon has an ability to bind. I mean, carbon is a very promiscuous molecule, so it is liable to bind with things. And there could be that in certain structures of carbon, it may have the ability to remove cyanotoxins from the environment. And so this is what water companies do. They treat it with these particulates. They treat it with not just powdered activated carbon. They also treat it with granulated activated carbon as well. So it's interacting with it on a number of different structural levels. I mean, they also use UV sterilization as well, but that's mostly just to kill the blue-green algae. The problem is killing the blue-green algae itself doesn't fully denature the cyanotoxins. So they have to go through a number of other processes to remove it. But the activated charcoal is actually the main one that they use. There are filtration systems as well. So what you need to do then is it's a similar process happening in nature in the wild. When the snows are melting, even if they've got a high concentration, I have to say I haven't tested this, so I'm trying to use logic here, and God knows that's not easy for me. But it appears to be, what they do is in nature, as the snow melts, it will then be introduced into the food cycle, into the what's the hierarchy called with food? Whatever. Anyway, it's into the food chain. Thank you. Where were you? It's introduced into the food chain, but because it's being, it's going through various stages of like being in the earth and then being absorbed through roots into grass, and then going through grass into animals, and then coming to predators through prey animals. It appears that through that process, nature is able to deal with cyanotoxins quite well, and therefore it's not raising the risk for most people to accumulate these cyanotoxins in their body or be exposed to them. And actually, I was very interested to look into, could this be an evolutionary factor adding pressure to longevity? And so I did start to look at, which are the most successful creatures that have ongoing longevity. And it would appear to be that a lot of the creatures that do hold records for longevity often are like bottom-dwelling creatures. So here I noticed that koi, while koi are obviously mostly ornamental fish now, their natural environment would entail them to very rarely come to the surface. So they would usually sit on the bottom, and then they would scurry through whatever lay on the bottom of the riverbed or the lake they were on. So very rarely would they be interacting with anything on the surface, which is, as you know, is where the green blue algae would be located. Going on, obviously, bowhead whale, another one that has great longevity. Animal has great longevity. Again, deep sea, not going to be seen very often in warm waters or near the surface. It's simply the case that if you are exposing yourself more to cyanobacteria naturally through your behaviors in your environment, you are going to suffer repercussions from that, because these long-lived animals don't do that. to have greater longevity, you need to avoid this. It appears to be from the evolutionary information that we have about what has survived. Rough-eyed rockfish, same situation again. Deep water fish, cold water fish. That seems to be an ongoing trend. And when you ask yourself, why is this the trend? Well, there are a number of factors. I'm not denying that there aren't. There are lots of factors that are indicated, like low predator activity, where there's less ability to see your prey. That's going to give you a better chance of evading predators. Of course it is. Just lower population density in these areas as well. These are all contributing to genetic pressure, to evolutionary pressure, to exist in these environments. However, I think there is a good case to argue that avoiding cyanobacteria and cyanotoxins specifically, once you've got a pretty functional CNS, seems to be quite a large factor in longevity. And you'll see that even in human populations. Well, I'll look at the tortoise first. The tortoise actually gets almost all of its water directly from its food. So it's already been processed. It's already been metabolized, and hopefully the cyanotoxins have been metabolized out by the point that it eats it. It eats a lot of the fruit, it eats a lot of the grass. It doesn't tend to eat that much meat, even though there's no problem with eating meat. The water that's included in many meat sources is directly ingested water that then will persist on. It's only having one abstraction, one layer of metabolizing, when really you want there to be multiple layers. For increased longevity, it seems to be the case anyway. And as I stated before, we're seeing, even from this, the EPA.gov own figures is showing that we are seeing higher temperature in the water globally. Global sea temperatures, especially on the surface, are rising. This is going to increase incidence of blue-green algae plumage, which is the point when you're going to get the evaporation of the cyanotoxins into the atmosphere, and then it's going to again come down as precipitation. Or it doesn't even have to enter the water system. It doesn't even have to enter the water cycle. It could merely be that it's evaporating offshore and then being blown in as water vapor in the air. So it doesn't have to go all the way up to the cloud layers. It can just be coming in off the sea, off of rivers, especially if they're very wide deltas, which would have a large area of relatively shallow water, but also access to blue-green algae. That's going to heat up easily and contribute to these large plumages, these large plumes, and they're going to have this water vapor coming off that includes the cyanotoxins, and then it's going to come into cities. I think you may be able to see, I'm not sure, I haven't run any experiments on this yet, but if you were to look up data regarding incidence of neurodegenerative conditions, I predict you would see that coastal cities that have weather patterns and wind patterns that actually drive air inland, not out to the sea, but inland, you're more likely to see, as long as they're in temperate or tropical zones that are susceptible to blue-green algae plumage, you're going to see more cases, I believe, of neurodegenerative conditions in those areas. But again, as I stated earlier, it could be a matter of, it's not necessarily that exposure equals pathology. It could be that the more exposure you have increases your potential for that to happen. Or the more people that are exposed, you then have a more diverse population, which may include individuals that have some sort of genetic mutation that no longer correctly processes BMAA, or no longer correctly processes or excludes or transports out of the body these cyanotoxins. But as long as you're increasing the numbers and increasing the exposure, you're going to see more cases overall. I apologize. The truth was I was reading so much about it that I decided I had to make a video. And so this is all off the cuff. None of this has been prepared. It's just as I'm remembering it, I'm trying to apply it so that it's available for you to digest in a much more condensed format than hours and hours of reading scientific studies. But there have been, as I said, like here's one of the studies that was done in assessing cyanobacterial harmful algal blooms as risk factors for ALS. And the conclusions they came to I mean, it broadly agrees, but it kind of puts it more down to, well, this is the state of play at the moment, and historically we can see this. It doesn't, I believe, make any predictions for the future. It doesn't accommodate for what appears to be like scientifically backed research into what our climate is going to look like in the future, and therefore it doesn't make predictions. Okay, it doesn't really make enough predictions for me to support it and be like, okay, this is something people need to take notice of, because it's just looking at the historic evidence, and the historic evidence obviously points to things like, you know, it's just so unlikely to happen, and it's in such low numbers that it's difficult to draw any conclusions. However, what I imagine what we're going to see moving forward is more and more younger people they won't need a lifetime of exposure to have the required dosage accumulate. They'll be able to accumulate much faster and much younger. And of course, there is obviously greater genetic diversity now. So you are seeing, you know, with more genetic diversity, you're going to see more mutations that cannot compensate for the cyanotoxins. However, you know, we do need to account for that as well, separate to the information the evidence seems to point to increasing opportunity for that to happen. We need to also understand that, all right, maybe as a population we're becoming more vulnerable to it as well. But yeah, I think I've said pretty much everything I want to say here. There is more information out there. You can look it up. There have been multiple studies done on these hotspot areas where there's blue-green algae blooms, and, you know, is there a strong correlation? And it is an area of ongoing research, but again, I don't think there's enough being done to emphasize to people this could be a fast-moving situation. If climate change is taking the course which many people think it is, could we see this be really the next large health crisis that we need to address? And if so, it's a terrifying one, considering neurodegenerative conditions are extremely difficult to treat, extremely difficult. It's a hard area to access. It's a hard area to make changes in and to do something meaningful about. So prevention is especially important, I think, in these areas. More so than I would say in like virology. I think virology prevention is important, but I think in neurology you're going to see more strives for prevention, at least until we're able to get ahead of some way of consistently accessing interventional treatments into the CNS, where it is currently so difficult to do. All right. Okay, well, thanks very much for listening. I hope this has been informative for you, and I don't mean to depress anyone or scare anyone. I'm just hoping you take this information into your life and you utilize it and understand that it is just my interpretation of the evidence. There have been very few studies that fully encapsulate what I'm saying or make predictions like I'm trying to speculate on here. So there's no need to take it as like a given that this is definitely what's going to happen. However, I think stay out the rain if you can help it, especially if you're aware of like local blue-green algae blooms. I mean, most people do. Most people do stay out of the rain. This is the thing, is if I begin to identify people who are like, no, I'm going to go out in the rain regardless, these are people who are driven to do something in an outdoor capacity. And you would see the armed forces in that environment. You would see athletes in that environment. You would see hobby cyclists and sports people who, you know, by the nature of what they're doing, they go for very long distances without cover from the elements. Like, this is part of what is ingrained in their behaviors. And whereas if you look at the behaviors of these other animals that seem to have great longevity, often they are mostly secluded. You know, they stay away from things. And I'm not saying that us being a herd animal have to follow that behavior precisely, but maybe we can take some of the beneficial elements of that behavior and incorporate them into what we do. All right, well, take that as you will. I hope you found that informative, and see you guys around.